The James Webb Space Telescope has unveiled something truly extraordinary, beams of light that seem to radiate from what appears to be an urban center, shining from a location light years away. This stunning discovery has sparked renewed excitement about the potential existence of extraterrestrial life. When the telescope directed its powerful gaze toward Proxima Centauri b, the closest exoplanet to our solar system, it observed strange, brilliant flashes of light. Could these be signals from an alien civilization? The possibility has captivated the scientific community and the public alike. For years, humanity has been fascinated with the question of whether life exists beyond Earth. Any evidence pointing to life elsewhere in the universe has always been met with tremendous enthusiasm. But a pivotal moment arrived when the James Webb Space Telescope detected what may be the clearest signs yet: lights resembling those from cities, on a planet far beyond our solar system. This exoplanet, Proxima Centauri b, could potentially host an alien metropolis. Such a discovery marks a significant milestone and has reignited hope among scientists who have long sought definitive proof of life beyond Earth. What makes this discovery even more intriguing is the distance involved, over 4 light-years away. The idea that such artificial lights could have been shining for centuries, waiting for our technology to advance enough to detect them, is both humbling and thrilling. David Kipping, an astronomer at Columbia University, described the planet where these lights were observed as especially complex. Unlike most rocky planets, which absorb sunlight and emit energy as infrared radiation, this particular exoplanet interacts with its host star, Proxima Centauri, in a unique way. The James Webb Space Telescope's ability to observe infrared wavelengths was crucial in capturing this phenomenon. These observations are helping scientists better understand the planet's atmospheric makeup and how it reacts to its environment. The plan is to continue using the telescope to study Proxima Centauri b's atmosphere in greater detail, especially to determine if it could support life. One of Webb's key strengths is its capacity to observe even the faintest glimmers of infrared light in the vast darkness of space. This makes it an ideal tool for confirming whether the alleged city lights on the dark side of Proxima Centauri b are real. If the lights fall within a specific frequency range, one that differs from natural starlight, the telescope could provide compelling evidence of artificial illumination, possibly generated by an advanced civilization. Proxima Centauri b's interaction with its star heavily influences its environment. Like Earth, it experiences cycles of day and night, but the temperature differences are much more extreme. If the planet has an atmosphere, it could experience intense heat on the day side and freezing temperatures on the night side. This dramatic thermal fluctuation is a critical clue for astronomers because it reveals important details about the planet's atmospheric conditions. Interestingly, the orbit of the James Webb Space Telescope around Earth aligns well with Proxima Centauri b's orbital period, approximately every 11.2 Earth days, allowing scientists to gather detailed observations over time. If the planet does have an atmosphere, researchers will then attempt to analyze its chemical composition, looking for signs of water vapor, methane, and oxygen, indicators that could point toward the possibility of life. Although the James Webb Space Telescope is incredibly effective at detecting elements like water vapor, carbon dioxide, and methane, it's less capable of identifying free oxygen. Nevertheless, it can still detect related compounds like ozone, which would be a strong sign of a breathable atmosphere. Each new data point helps astronomers inch closer to answering the ultimate question: are we alone in the universe? Despite its advanced capabilities, the Webb telescope can only observe a limited number of nearby exoplanets. For more comprehensive atmospheric studies, scientists are eagerly awaiting the arrival of ground-based observatories like the Extremely Large Telescope, ELT, scheduled to begin operations in 2027. The ELT is expected to offer a deeper and more precise look into exoplanet atmospheres, enhancing our ability to determine which worlds might harbor life. Meanwhile, the James Webb Space Telescope continues to serve as a critical tool in the exploration of distant worlds. Future missions aim to build upon its legacy with technologies designed to overcome one of astronomy's biggest challenges, blocking out the intense light of stars to better observe the faint reflections of nearby planets. Much like shielding your eyes from the sun with your hand, These technologies help astronomers see what's otherwise hidden in glare. Among the most promising of these innovations are coronagraphs, devices placed within telescopes to block starlight while allowing planetary light to pass through. By reshaping the way light enters the telescope, coronagraphs dramatically reduce the brightness of stars, making it easier to detect dim planetary glows. Another breakthrough is the Starshade, a massive flower-shaped spacecraft that flies in formation with a space telescope. Positioned tens of thousands of kilometers away, it blocks starlight before it even reaches the telescope, letting only the faint light from exoplanets through. These high-precision instruments must operate with extraordinary accuracy. For example, the alignment of a starshade must be perfect to within fractions of a millimeter across vast distances in space. Additionally, these systems must be miniaturized, energy-efficient, and durable enough to survive the harsh conditions of space travel. Despite these engineering challenges, the scientific potential is enormous. Detecting biosignatures, chemical indicators such as specific ratios of methane, water vapor, and oxygen, could finally prove the existence of biological processes on distant planets. In other words, it might be our first true evidence of life beyond Earth. Researchers are also working on technologies that can directly image exoplanets in greater detail. Future space telescopes could be equipped with adaptive optics that correct for distortions caused by Earth's atmosphere or the telescope's own movement. These improvements, when combined with starlight blocking techniques, may enable scientists not only to detect distant exoplanets but to map their surfaces, observe their climates, and assess their potential to host life. This next generation of space telescopes represents a giant leap forward in humanity's quest to understand our place in the universe. By enhancing our ability to study planets light years away, we edge ever closer to unlocking the secrets of life beyond Earth. The future of space exploration is unfolding before our eyes, and it's happening faster than ever before. As astronomers dig deeper into the mysteries of distant worlds, the James Webb Space Telescope is ushering in a new era of cosmic discovery. Its findings are helping scientists make groundbreaking revelations about planetary composition, structure, and habitability. Each new discovery brings us one step closer to answering that age-old question: is there life beyond our planet? The recent discovery related to Proxima Centauri b might only be the beginning. As the closest known exoplanet to Earth, it has long been the subject of speculation and intense research. Until now, dreams of discovering artificial light or alien civilizations remain just that, dreams. But the Webb telescope's detection of strange light emissions has changed that narrative, fueling both scientific curiosity and public imagination. This groundbreaking find may inspire a new generation of explorers, scientists, and thinkers to look up and wonder what lies beyond our sky. As the James Webb Space Telescope continues to observe exoplanets, it's not just searching for city lights. It's analyzing atmospheres, studying chemical compositions, and examining environmental conditions, all crucial steps in identifying planets that could host life. One especially captivating feature of Proxima Centauri b is its position within its star's habitable zone, the region where conditions may be just right for liquid water to exist. Water is fundamental to life as we know it, making such planets prime targets in the search for extraterrestrial life. Proxima Centauri b is also believed to be tidally locked, meaning one side always faces its star while the other side remains in perpetual darkness. This phenomenon creates intense temperature gradients that could affect the climate and overall habitability of the planet. Understanding how these extreme environments work is vital for assessing the likelihood of life on such worlds. Finally, technological advances like the coronagraph and starshade are revolutionizing space exploration. These tools allow astronomers to pierce through the blinding light of stars and study the planets that orbit them. Without these innovations, detecting the faint, flickering lights from distant worlds would be nearly impossible. With every advancement, our dream of finding life beyond Earth becomes more tangible. And with telescopes like James Webb leading the way, we may soon find ourselves standing at the edge of one of the most profound discoveries in human history. Stay tuned to Discovery at 2.0 for updates as we continue to unravel the mysteries of our universe, one light, one signal, and one world at a time.